Hello everyone, welcome back to Cloud Computing Series. This is the Unit 3 Important Questions Solved video. Before starting, if you are new to EduWorld, then subscribe to it for more videos like this. These are all the important questions from Unit 3. Let us start with the first question. What is virtualization? Explain the types of virtualization and their role in cloud computing. Let us start. The virtualization is a technology that allows one physical machine to run multiple virtual machines. And each virtual machine acts as a separate computer with its own operating system and applications. Here, it is a technology, it will allow physical machine to run multiple virtual machines. And here, each virtual machine acts as a separate computer and it has its own operating system and applications as well. And here, the virtualization improves the hardware use and reduces the cost as well. These are all the types of virtualizations: hardware, operating system virtualization, server virtualization, storage and network virtualization. Let us start. Hardware means physical hardware is divided into multiple virtual machines using hypervisor. Let us see hypervisor in the next upcoming questions. Physical hardware, the physical hardware which is divided into multiple virtual machines using hypervisor. For example, VMware and VirtualBox. Operating system virtualization means multiple isolated user spaces runs on the single operating system. The multiple isolated user spaces runs on the single operating system. This is the operating system virtualization. For example, containers like Docker. This is an example of operating system virtualization. The next one is server virtualization. One physical server is split into many virtual servers. That is server virtualization. Each server runs independently. Here the each which is splitted the servers, right? The each virtual servers runs independently and this is used in the data centers. And storage virtualization means multiple storage devices are combined into a single storage pool, which means the multiple storage devices which are combined together to form a single storage pool. And it improves the storage management and performance because I can store how much ever data I want, I can easily store. By that, it can improve the storage management and performance as well. Network virtualization, it combines the network resources and divides them into virtual networks. For example, VLANs, software-defined networking. This is all about the virtualization and its types. Let us move to the next question. Explain the architecture of virtualization with neat diagram and describe how it improves the resource utilization. Here I have explained the virtualization with an example. The architecture shows how virtualization creates a virtual data centers where applications and the infrastructure run on shared cloud resources. In the architecture, I have application management and infrastructure management. Let us see. The application management means it manages all the apps like Windows, Linux, .NET, SAS, desktop, etc. running in virtual machines. If I see, I have .NET, SAS, Windows, Linux and desktop apps, everything I have. These will manage under the application management. Clear? Application management. And the second one is infrastructure management. Here, infrastructure management, it manages the underlying physical hardware used by the virtual environment. Clear? And I have here application virtual services which will provide the availability, security and scalability in the cloud. The application virtual services which provides the key services such as availability, security and scalability to the applications inside the cloud. And the next one, virtual operating system and data center. If I see here, virtual operating system and data center, which provides, this is a main layer that creates the control virtual machines. After that, it hides the physical hardware and provides the virtual CPU, virtual memory, storage and network to each virtual machine. And I have cloud virtual services here. It provides the cloud specific features like backup, monitoring and load balancing, VM management as well. Clear? And I have on-premise cloud and off-premise cloud. Let us understand about that also. It shows the virtualization works in the both private clouds and public clouds. Clear? This is all about the virtualization architecture. And they have asked that describe how it improves the resource utilization. Let us understand that also. Multiple VMware's virtual machines share the same physical hardware that I have explained previously. So no resource remain idle. And CPU, memory, storage are allocated dynamically based on demand only. And unused resources of one virtual machine can be used by another virtual machine also. That's why the resource allocation, it improves the resource utilization. Physical hardware is used more effectively, reducing the waste also. And cloud providers can run many customers' VMs on fewer services. And better utilization leads to reduced costs as well, higher efficiency and improved performance. By this, I can easily say that virtualization improves the resource utilization. Clear with this question? Let us move to the next one. What is hypervisor? And explain the types of hypervisors with example and their advantages in cloud environments. Hypervisor is a software layer that creates and manages the virtual machine. It will create and manage the virtual machine. It is a software layer. It sits on the top of physical hardware and allows the multiple operating systems to run at the same time on the physical machine. Because of the hypervisor, each virtual machine works like a separate computer. Clear about this? What is a hypervisor? Types of hypervisors I have type 1 and type 2. Type 1 means Bare metal hypervisor. It runs directly on the physical hardware only. It doesn't need any operating system below it. For example, Microsoft Hyper-V, VMware ESXi, Citrix, Zen Server, and KVM, that is kernel-based virtual machine. The features of this Type 1 hypervisor is fast, highly secured, best for the data centers and cloud providers. It will work best for the data centers and the cloud providers. It is all about the Type 1 hypervisor, that is bare metal hypervisor. The second one is Type 2 hypervisor, that is hosted hypervisor. It runs on the top of existing operating system only. The operating system must be installed first. Then the hypervisor is installed as software. First, it has to install the operating system. After that, the hypervisor. For example, Oracle VirtualBox, VMware Workstation, VMware Player, and Parallels, that is Mac. Features are easy to install, best for personal use, testing, and development as well. They have asked the advantages of hypervisor in cloud environment. Better resource utilization, cost reduction, isolation, scalability, easy VM migration, security, and fast deployment. These are all the advantages of hypervisor in cloud environment. You have to write the explanation for each based on the marks only. Clear? The next question is explain the challenges and issues in virtualization such as performance, security, and VM migration. The challenges are, we have many challenges, that is performance issue, security, VM migration, management complexity, licensing issue, and backup and recovery challenges. These are all the major challenges that we see in the virtualization. Clear? They have told to explain the performance, security, and VM migration. Performance issues means virtual machines share the same physical CPU, memory, and the storage. That is the issue here. And when many VMs runs together, performance may decrease. That is the challenge. And disk input output and network input output become slow if overloaded. If there is any overload, it will work slowly. Some applications may not perform well in the virtual machines because of the overload. Next one is security issue. A single infected VM can affect another virtual machines if isolation is weak. If the isolation is weak and one virtual machine is affected, then it will affect the other virtual machines also. Hypervisor attacks. Hacker may try to control the hypervisor itself. That's why this is also a security issue. Data leakage can happen if virtual machines share the resources improperly, and misconfigured virtual networks can allow the unauthorized access also sometimes. That's why these are all the security issues that we can see in the virtualization. And the third one is virtual machine migration issues, which means when moving a virtual machine from one host to another, then there also we can see the issues in the virtualization. Let us understand. Live migration requires high bandwidth and stable network. If it is not there, then it is a disadvantage, which means it is a challenge. Migration can slow down the applications during data transfer also. During the data transfer, it will slow down the applications, and different hardware between servers may create the compatibility issues as well. Storage mapping may fail if not managed properly. Migration failures can lead to the downtime or data loss. If the migration fails, then the data loss may happen. And the next one is management complexity. Hard to manage many virtual machines and difficult to monitor and allocate the resources as well. Licensing issues means sometimes software doesn't support the virtualization and license cost may increase. This is also a challenge. Backup and recovery challenge. Snapshots need large storage, should have the storage properly, and restoring virtual machines is slow and difficult. These are all the challenges and issues in virtualization. You have to write based on the marks only. And the next question is, what is the MapReduce programming model? Explain its working with the simple example of MapReduce function. MapReducing is a programming model used for processing and analyzing large data sets in a distributed cloud environment. If I have a large data sets, I can easily analyze and process by that in a distributed cloud environment. This is MapReduce. It breaks the data processing into two main functions, that is map and reducing. By name, I can easily understand map and reduce. Two functions I have here. It helps in parallel processing across multiple machines efficiently. Here you can see right parallelly, it's processing across the multiple machines efficiently. Map and reduce. Working of MapReduce, map function, it processes the input data and converts it into key value pairs. It will process the input data and convert it into key value pairs. Each input is processed independently in parallel. Each input is processed independently in parallel. Clear? Shuffle and sort. Here key value pairs from all map tasks are collected, stored and grouped by the key and prepares data for the reduce function. Here the shuffling will happen, shuffle and sort. And reduce function, it takes the grouped key value pairs. It will take the groups of the key value pairs and performs aggregation, summarization and computation here in the reduce function. After that, it produces the final output and send here. Here it works in parallel across multiple machines. Parallelly, it will process and work. It handles very large data sets efficiently. If I have the large data sets, it will work efficiently with that. Widely used in cloud platforms like Hadoop. It is widely used in. And the next question is, describe the MapReduce architecture and explain how it supports large-scale data processing in cloud environments. This is also similar to the previous question. But here they have asked the MapReduce architecture, which is very similar to the previous one. Let us see once again. Here the components are job tracker or resource manager, resource manager, task tracker or node manager, input data split, and map function, shuffle and sort, reduce function, output storage. These are all the components present in the MapReduce architecture. Job tracker means here it manages the overall processing, schedules the task, and monitors the progress here. Task tracker means it executes the task assigned by the job tracker on worker nodes. Input data splits means the large data sets are divided into smaller chunks, usually stored in a distributed file system like HDFS, that is Hadoop distributed file system. And map function means processes input data chunks independently and producing the intermediate key value pairs, same as the previous one. Shuffling and sorting. It organizes and groups the intermediate key value pairs by the key, preparing them for the reduction. And reduction for reduce function means the aggregates and processes the grouped key value pairs to produce the final output. Output storage means the result are stored back in the distributed file system for further use. Whatever I have explained in the previous question, the same here also. Draw this diagram for MapReduce architecture. And the workflow is input data is splitted and distributed across the multiple nodes. And map tasks run in parallel on each node to process the data locally. Clear? And next one is intermediate results are shuffled and stored across nodes by keys. And reduce task process the grouped data to produce the final output, and the final results are saved in a distributed storage system. The same things whatever I have explained here. This is the workflow. How MapReduce supports the large scale data processing in cloud environments by scalability, fault tolerance, parallel processing, data locality, and cost efficiency. By these features, the MapReduce supports the large scale data processing in cloud environments. You have to write the detailed explanation if it is needed. And the simple examples I have taken, the task is count word frequency in a large text files. You have to count the word frequency in a large text file. Mapping means what it will do means each node reads the chunk and emits key value pairs like word 1. Like that, word occurred one time. The word has occurred once. And shuffle and sort function, it will group all the identical words together. Reduce function, it will sum the counts for each word and output. Word and the total count. How many times it has occurred. This word has occurred one time and the next word has occurred 2 times, like that. The architecture makes processing huge data set in distributed cloud environment efficient, reliable, and fast. By doing this, the cloud architecture will be very fast, reliable, and efficient. And the next question is, what is Cloud Haskell? Explain its features and how it supports the distributed programming in the cloud. The Cloud Haskell is a set of libraries that helps Haskell programs to run in a distributed way across multiple machines. And it provides an Erlang style message passing model, so processes can communicate easily without dealing with the network. Without using the network, the message passing is very smoothly handled here. The features are message passing between the processes, location transparency, which means sending the messages anywhere, lightweight processes, fault tolerance, which means the process monitoring, scalability across many nodes. No need to write the networking code here, because without using network only, we can easily message passing can happen here. How it supports the distributed programming in the cloud. It runs processes on different cloud machines. By that, it will support the distributed programming, and it splits the large tasks to run in parallel, which means it is splitting means distributing is happening. Clear? Automatically handles the failures as well, can scale up or down when the cloud nodes change. And it makes distributed programming simple and reliable. This is all about the Haskell and how it supports the distributed programming as well. And the next one is compare Cloud Haskell and MapReduce. Cloud Haskell, it is a programming model for message passing and it is distributed process. MapReduce is a functions for batch processing. And data handling works with the message design processes only. It works with key value pairs. And it is real-time, interactive, and concurrent task. It is large-scale batch data processing. It is used in the chart system, distributed apps, and cloud services. The MapReduce is used in the data analysis, log processing, big data task. It scales by adding more distributed nodes, and it scaled by parallel map and reduce task. The fault tolerance is happened by process monitoring and recovery. It is the automatic task re-execution on failure. It is very flexible, supports many distributed patterns, and it is rigid, suitable mainly for the batch jobs. And the programming style is general purpose distributed programming. It is data parallel computation. It is best for cloud applications requiring communication, and it is best for heavy data processing across big clusters. This is all about the Cloud Haskell and MapReduce. The next question is, explain the software development in the cloud and describe the tools, platforms, and environments used in cloud-based application development. The software development in the cloud means using cloud services to build, test, deploy, and run the applications in online. It provides fast development, easy scaling, and teamwork support. The software development in cloud, the key points are developers write and run the code using cloud services. Applications are built, tested and deployed on cloud platforms itself, and the cloud provider, it provides the on-demand services only. Whatever you needed, it will provide that service based on your need, storage, database and the tools. It enables faster development, easy scaling and team collaboration as well. The tools, platforms and environments used in cloud-based development are Cloud IDE, version control tools, CI/CD tools and many more. I'll explain. Cloud IDE means online code editor. For example, AWS or Cloud9, Gitpod, Replit. These are all the examples. The features are code editing, debugging, terminal access, and built-in environments. Version control tools are Git, GitHub, GitLab, and Bitbucket. These are all the examples for version control tools. Purpose are manages the source code. GitHub and GitLab, those will manage the source code and supports the collaboration and tracking changes. CI/CD tools that are automation for build, test, and deploy. For examples, Jenkins, GitHub Actions, GitLab, CI/CD, and Circle CI. The purpose of this are automates the software build and testing also is done in that deployment pipelines. And the next one is cloud platform, that is PaaS, IaaS and SaaS. For example, AWS Elastic Beanstalk and Google App Engine, Microsoft Azure. The purpose are it provides the servers, storage, runtime environments and automatic scaling as well. Containerization tools, for example, Docker and Kubernetes. The purpose of these are package design deploys applications in lightweight, portable containers. And the serverless platforms are AWS Lambda, Google Cloud Function. The purpose of this are developers run the code without managing servers only, and cloud handles the scaling very well. Database services, for example, Amazon RDS, Firebase, MongoDB, Atlas. The purpose are cloud hosted databases that scale automatically, and testing tools, that is Selenium, Postman, and JMeter. The purpose are cloud-based testing for web apps, APIs, and performance. Development environments such as sandbox environments, virtual machines, containers, and online testing labs. The project management tools are, for example, Jira, Trello, and Asana, which helps plan, track, and manage the cloud development work. These are all the tools, platforms, and the environments used for cloud-based application development. And the next question is discuss the benefits and challenges of developing, testing, and deploying the applications using cloud programming models. The benefits are cost saving, which means no need to buy hardware and pay only what you use. Pay as per you use. And scalability, which means easily increase or decrease the resource based on the demand only. Faster development, which means ready-made tools, APIs, and cloud services speed up coding. That's why faster development. Easy testing, which means cloud provides the multiple testing environments instantly. That's why the testing is very easy. Automatic development, automatic deployment. CI/CD pipelines make the deployment quick and error-free as well. And high availability. Cloud system provides the backup, failure, and global access as well. That's why high availability is there. And team collaboration. Team can work together from anywhere using shared cloud tools. That's why team collaboration. This is also benefit of developing, testing, and deploying the applications in the cloud. And the next one is challenges. What are the challenges we face in the cloud-based development, testing, and deployment? Security issues are there. Data stored on cloud servers may face the security risks sometimes. And dependency on internet. Here, development and the deployment needs the stable internet connections. If it is not there, then we have to face the challenges. Vendor lock-in. Migration from one cloud provider to another is very difficult here. And performance issues, network latency can affect the application performance. It may decrease. Cost overruns. Poor resource management can increase the cloud bills. And complexity of tools, cloud-based tools and platforms may require skilled developers. Here, this is the main challenge that we face. And data privacy and compliance. Here, must follow the strict rules when handling the sensitive data, or else we will lose the data. Data losing may happen. These are all the challenges of cloud-based development, testing, and environment. Here completes the Unit 3 of Cloud Computing. You can easily access these notes by clicking below the link I have provided. If you found this video helpful, then subscribe to Shiva EduWorld for more videos like this. And if you want me to explain any particular subject or topic, comment below and let me know. And share this video with your friends who are struggling in cloud computing. Thank you very much for watching. See you in the Unit 4 video.